Welcome back to part 5 of 5.8, 5.9 Calculus AB. So now we're looking at this, sketching again the possible graph for f of x with the following characteristics. So we're looking at f prime of x is greater than 0 for all x, and then f double prime of x is greater than 0 for all x as well. And then we're given a point which is part of the function f of 1 equals negative 2. So remember, according to the derivative test, right? So one thing that I didn't show you guys that might make it a lot easier for you is certain characteristics of this. So this might help when creating graphs. So f is positive, negative, it's increasing, decreasing, and then concave up, concave down. And then f prime, right? If f is increasing, that means that f prime is positive. If f is decreasing, that means that f prime is negative. And then we continue with the same pattern. We draw the same little things right there. And then f double prime, right? So if f double prime is positive, that means f prime is increasing, and then that means that f is concave up. If f double prime is negative, that means that f prime is decreasing, and then f is concave down. So hopefully this helps a little bit more, just to clarify some of the things that you guys had. Okay, here it goes. So here f prime is positive, right? If f prime is up positive, that means f is increasing for all x. So we're looking at a graph that's always increasing, right? It always has a positive slope. And then f double prime is greater than 0. So that means if f double prime is also positive, that means f is also, it's concave up. And we are given a point. So we're going to plot that point first. We got to make sure that our graph goes through there. And then something that's always increasing, it looks kind of like an exponential function. And it's always increasing, and it would be just a curve, right? So as long as we have positive slopes that are always increasing and then concave up, going through the point of f1 comma negative 2. And looking at example B, so f prime is positive, meaning f is increasing for x greater than 1. F prime is negative, right, less than 0 for x less than 1. And they're also telling me that f prime of 1 is equal to 0. Since they're telling me this is also a critical value, meaning we're going to have either a maximum or a minimum value. And then f double prime of x is greater than 0 for all x. For all x, this means that f should be concave up all the way. All right, so f of x should be concave up. And then f1 is equal to negative 1, so that's one of our points. All right, and then we have a critical value at 1, so therefore, and then it changes sign, right? F prime goes from positive to negative there. So that means we're looking at a graph that kind of looks like a parabola. We don't know necessarily what f is, but at least we can know what shape it has. So this meets all the conditions. F prime is greater than 0 when x is greater than 1, right? It's on this side. F prime is less than 0 when x is less than 1, which is on this side. It's decreasing. F prime is a critical value, f prime of 1. And then f double prime is always positive, meaning it's always concave up for all x. And now looking at C, we have f prime of x is greater than 0 for x greater than 2. And then f prime of x is equal to 0 for x less than or equal to 2, meaning we have a flat slope here until we reach that value 2. All right. And then f double prime is positive for x greater than 2. And then they're also giving us a point, f2, 1, which would be right there. So this means it's kind of like a piecewise function. When we hit positive 2, it's going to start to increase, right? So it's going to be concave up. So we're looking at a graph that's flat. It's flat. It reaches this value here and then starts to increase. Like so. So again, this is where it changes, right? It becomes positive, so it starts to increase as well. And now looking at D, we have f prime of x is greater than 0, meaning f is increasing, right? F is increasing at x equals greater than negative 1, sorry. F prime of x is less than 0 for x less than negative 1. It's that meaning f is decreasing, going down. And f double prime is less than 0 for x not equal to 1. And then f of negative f of -1 equals -2. So that's a point we got right there. So they're not telling us that we have a critical value at -1, but they are telling us that it changes there, right? It changes at -1. So the graph will always be concave down, right? That's another important feature. The graph will always be concave down for all x except at 1. So when we get to -1 comma -2, we reach a value that it might be just it's f prime is undefined there. So when we have it undefined, that's when we usually have a cusp or something. So our graph again is always concave down, and then it hits that point, and then again continues to be concave down except at that value. And then looking at E, we have f prime of x is greater than 0 for x less than -3. F prime is less than 0 for x between -3 and +1. And then we have f prime of x is greater than 0 for x greater than 1. F prime is of -3 is equal to f prime at 1 is equal to 0. So that means we have two critical values right here. These are the critical values. And then we're given a point f of 0 is also equal to 0. That's another critical. Oh, no, that's not a critical value. It's just a point. Right? It's not f prime. And then they're telling us the graph is concave down up until it reaches -1, and then concave up when it reaches, again, crosses -1. All right. So looking at this graph again, we have our first value right there. We have a maximum at -3, right? Because we changed from positive to negative at -3. And then we also have a minimum at 1 comma -1. Yeah, because it has a 0 right there. And then from there, again, we can draw the graph. So we're positive up to we reach -3. So that means we're increasing from -infinity to there. And then our graph continues and it changes to negative. It goes through 0. And then it starts to decrease again and keeps going up and keeps going up and so forth. So, yeah, the minimum should be more closer to 1, but you guys get the picture. Kind of like that. So from there, we look at the final one. We have f prime of x is greater than 0 for x greater than 2. F prime of x is equal to -1/2 for x is less than 2. F prime of 2 does not exist. And f double prime is less than 0 for x greater than 2. And then f of 2 is equal to 0. So we have pretty much, if it doesn't exist, so remember, it could be either a cusp or like something like a tip, right? So for sure, we know that at 2, we have a 0. And then the slope is -1/2 until that point. So we have a point right there. And then again, it's just going to be a straight line going in that direction to the left. And then finally here, we start to increase and it's concave down. So concave down. So we have a graph that looks like this.